Let us try to understand the petrol engine and diesel engine in brief in this video. So to begin with, let us choose the petrol engine. Now how does it work, that we are going to see with the help of a PV diagram. On the x-axis we have volume and on the y-axis we have pressure. Let's just get diesel for a moment. It consists of a typical cylinder piston arrangement, and the piston can move up and down. In order to understand this, let us just invert this in a more traditional looking way so that the picture becomes clear. A typical petrol engine has two valves. One of them is called as inlet valve and the other is called as an outlet valve, and is fixed with a piston. This is a typical cylinder piston arrangement where the piston is movable. Along with this, it is introduced with a spark plug S, which is connected to some battery or some sort of mechanism which can generate sparks. What is the working substance in this case? The working substance is mixture of air and petrol vapor. So we require air for this process to take place along with the petrol, because air is the substance which burns during this combustion process. In the initial step, this inlet valve is kept open and the air is sucked from outside into the cylinder by a downward motion of this piston. This process is called as suction stroke and is represented by this arrow from point E to point A. So this first process or the first stroke is called as suction stroke, which sucks in the air and petrol, that is the fuel, into the cylinder. During this process, the outlet valve is kept closed. In the next process, this piston moves upwards so that this inlet valve as well gets closed. So this is the step where both of the valves are closed now and the piston moves upwards. So the mixture present inside is compressed. Not only that, here we assume that the walls of the cylinder as well as the piston material is completely non-conducting. So neither the heat can go outside this system nor it can enter into the system. So the change in heat in this process is zero and the gas is getting compressed. This is nothing but adiabatic compression. And again, since the piston moves, it is a stroke. So we should note that when we call a process a stroke, the piston is supposed to move. Now the piston moves upwards adiabatically. So it causes a compression, that is the decrease in volume. So yes, let us say this is the process A to B, which is the adiabatic compression stroke. In this process, both the valves are closed. And we know that adiabatic compression results in rise in temperature. Rise in temperature. The volume is reduced by almost 1/8. So that is a very quite large amount of change in volume. The temperature rises from say T1 to a value T2. Now this is the time to ignite this mixture of air and petrol. So a spark is produced with the help of a spark plug here, which ignites this particular mixture. As a result, both pressure and temperature rise drastically. The temperature values reach almost to 2000 degrees Celsius, whereas the pressure values reach up to 80 atmosphere. So these are just the typical values. They may change from engine to engine, but these are the typical values which can be realized. So process B to C is called as ignition, and since this is an instantaneous process where volume cannot change, we have to represent it by a vertical arrow on this PV diagram. The temperature rises further to T3. Now as a result of this process, the piston is going to move downwards due to the combustion taking place, and as a result the energy is released which pushes this piston downwards. Since again the piston is moving, this is a stroke, and it is responsible for the work, as if a wheel is attached to this piston, it is going to move during this motion. So this next step, T to D, is called as working stroke. Here again the gas now expands adiabatically, and as a result its temperature is dropped to say some value T4. The point is, let us say, T. At this stage of working stroke, when the system reaches at point D, note that till this point D, both of these valves are closed. Now the work has taken place and the mixture has already burned. So it has to be removed from this cylinder so that a fresh mixture is allowed to enter inside. For that, now a mechanism opens this outlet valve, and the piston is moved upwards so that this unburned mixture of air and petrol is released as an exhaust gas from this outlet valve. Again, since the piston is moving, it is called as exhaust stroke. So after the system reaches back to point A by cooling down from D to A, the stroke E to A is operated in reverse order, and the system goes back to point E by following an exhaust stroke. This is how an entire cycle is complete, and again we can start back our process from E to A by sucking in a fresh amount of fuel and air inside this cylinder. Work is performed during each cycle, and if this continuous supply of air and petrol mixture is kept on, this engine is capable of providing continuous amount of work. Let us just go through the formula for efficiency of this engine. Efficiency eta is given by 1 minus 1 by rho raised to gamma minus 1, where rho is nothing but the V2 by V1, which is the adiabatic compression ratio. That is the ratio which we have discussed here, that the volume is getting compressed, or the gas is getting compressed by a factor of 1/8. So this is that factor. So adiabatic compression ratio is typically 8 for a petrol engine. Of course, for all practical purposes, this value of rho has to be kept below the value 10. And why is it so? Because if we go on increasing the adiabatic compression ratio, since the adiabatic compression comes along with a rise in temperature. If this ratio goes above this value 10, the temperature rises to such a value that this mixture does not require any spark for ignition, and it gets burnt and exploded on its own due to a very high rise or high value of temperature. So there is a risk of permanent damage to the cylinder piston arrangement if the value of adiabatic compression ratio is increased beyond 10. So it also puts a limit on the value of rho, that is a limit on the value of eta. So this causes the eta to be less than or equal to 60%. So a typical theoretical petrol engine cannot provide an efficiency larger than 60%. This was a brief discussion of petrol engine or auto engine, as we have named it. It is also called as auto engine. Now let us have a view of diesel engine. Now let us see how does it differ from the petrol engine. The first fundamental change is that instead of two valves, it has three valves. Let us call them as I1, I2 and I3, and a cylinder piston arrangement as was it is in the previous case. Just a minute. Okay. Now note that it does not have any spark plug. So it does not require any external spark to produce ignition or to initiate ignition. Then it has three valves instead of two, as was the case with petrol engine. Further, of course, we are going to use diesel, which is a typical oil retrieved from refineries, as a fuel along with air. So this mixture is the working substance. Again, if we look at the process, the first step is exactly similar to as that of the petrol engine on a PV diagram. The exhaust, sorry, not the exhaust. The suction stroke causes the gas to enter through the inlet valve I1. So let us call it as E to A. So it sucks the required amount of fuel and air inside the cylinder. Then we have the compression stroke AB. After that, there is a slight change in the process. In the case of petrol engine, we had the isochoric process from B to C. Now instead of this, here what we have is an isobaric process from B to C. And it is called as combustion. Excuse me. So the valve I2 is opened so that fuel enters inside, and the compression causes a rise in temperature so high that it gets burned on its own. The pressure is maintained constant at this process, and due to burning process the temperature rises further, and it causes the combustion as well as the working of this engine, that is the motion of piston as the volume rises from a lower value to a higher value. This is also called as the working stroke. Now, since work has already been performed and the gas has already been burnt, now the process C to D causes the cylinder to further expand, the piston further move downwards through adiabatic expansion process C to D. And during the last step, denoted by D to A, where the temperature falls down from say T4 to T1. Let us denote the other temperatures as T1, T2 and T3. For this D to A process, this outlet valve I3 is kept open so that the pressure falls from a high value to atmospheric value. After the pressure falls to atmospheric value, the piston moves upwards so that whatever is left inside this cylinder is getting exhausted through this outlet valve I3, and the system returns back to point E from point A through the exhaust stroke. So this is how a diesel engine works. So if we just compare at the PV diagrams, we get to see the difference. In case of the petrol engine, the PV diagram was like this. In case of a diesel engine, the PV diagram is like this. But this causes a huge difference in the derivation of efficiency, because in this particular process only one type of specific heat, that is specific heat at constant volume, is involved, whereas in this case this process belongs to constant pressure, so specific heat at constant pressure is involved here, whereas this process belongs to constant volume, so specific heat at constant volume is involved here. So the derivation of efficiency of this engine becomes slightly complicated, so we are not going to go into the details of that. We'll just look at the formula for the efficiency. This is given as 1 upon 1 minus gamma. Note that this gamma is just the ratio of Cp upon Cv to 1 upon rho gamma minus 1. So of course it also depends upon the value of rho, which is the adiabatic compression ratio, into e raised to gamma minus 1 upon e minus 1. Note that E is the combustion compression ratio here. That is another ratio. But the advantage of using a diesel engine is that for this engine, the values of rho are typically ranging from 15 to 20. So that is just twice the value of the compression ratio for a petrol engine. Due to this diesel engine is much more efficient than its petrol equivalent. And as we can see that people prefer this diesel engine as it provides a higher efficiency. Of course, it comes with its own maintenance issues, but yes, it provides a higher efficiency. Thank you.